Welcome, ladies and gentlemen, to a topic on magnetism. Now, in this topic, we want to look at a permanent magnet, its properties, and what happens when a magnetic material is brought near a permanent magnet. So when you hear the word a magnet, what should come into your mind is any object that will attract or repel a magnetic material. We call that a magnet. Now, materials are of two types as regard to magnetism. There are those materials that are called magnetic materials, and the other name is ferromagnetic materials. These are materials like steel, iron, nickel. Now, these materials, when you bring them near to a magnet, they can be attracted. But materials that are not attracted to a permanent magnet, when you bring them closer to a permanent magnet, are said to be non-magnetic materials or non-ferromagnetic materials. Materials like rubber, plastic, wood, paper, glass, grass, those materials are non-magnetic. They cannot be attracted. So when you are given a magnet or you are given a material, how do you know that these materials that I have is a magnet? So properties of magnet would tell us whether the material that we have is a magnet. For example, when a material is magnetic, when you suspend it in air, it points in the north-south direction. And we all understand when we say north-south, we know this is north, this is south. So when you suspend a magnet in air, it will point in this direction, north-south. That one, it's a first property. The second property is a magnet will only attract magnetic materials. Meaning that if non-magnetic materials are brought near the magnet, none of the effect will be identified there. And in fact, the best way to test a magnet is use what is called repulsion. And what do we mean by this? When you have two magnets, let's say this is a permanent magnet, and then this is just a bar magnet, which we are testing. This one you know it, this one you don't know it. So you want to find out if this material is a magnet. So you are going to bring it near a permanent magnet. If this end and this end is attracted to this one, which is a permanent magnet, then this one is not a magnet. But if one of the end is attracted and the other end is repelled, then you tell that this is a magnet. Actually, the best method to test a magnet is repulsion. Remember, a magnet only attracts magnetic materials. Then another property is that like poles of a magnet repel, okay? And unlike poles attract. That's what you should know about a magnet. They attract. They attract. Like poles of a magnet repel, and like poles attract. Another property is magnets have two opposite regions where the strength is concentrated. And usually these are on the end of a magnet, and we call these regions as poles. So there's a north pole and there is a south pole. These are the regions where the strength of a magnet is concentrated, most of it. All right, Let's talk about what is called a domain theory of a magnet. Now, what you should bear in mind is when you have a permanent magnet, inside the magnet there are atoms. And what you notice is, for example, when you break a magnet, you realize that a piece from a magnet, also it's a magnet itself, it is able to attract other materials. It's because of the same concept of the domain. They have atoms in them, and these atoms form magnet on their own. Now, this is what you should understand. When a material is not magnetized, these atoms inside point in all direction. But when a material is magnetized, they change and point in the same direction. So what will happen is they will also form a magnet. For example, this also becomes south, 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 south. Meaning that if I was to cut a magnet here, this part also becomes a magnet. If I cut it here, it also becomes a magnet. So this is how a magnet behaves. Thank you for watching.